How can you make sure your embedded system's functional specification will comply with some safety requirements? Once you have developed a specification, you also need to check if it cannot violate the safety requirements you have identified. Making sure that a specification based on natural language requirements is correct is already a very difficult challenge. Making sure it will not violate the safety just using the classic review is even more difficult. Discover how you can achieve your safety goals using stimulus and how you can achieve a much higher level of confidence with much less effort. When you write your functional requirements in stimulus, you will use block diagrams for the architecture, state machines, and a customizable and extensible set of textual templates to describe the system component's expected behavior. Stimulus simulation capabilities will enable you to find erroneous, missing requirements, or also conflicting requirements. You will find many errors that today go through the reviews without being detected.
70% of the errors are in the requirements, but classic reviews only detect 4%.
Now, let's imagine that after multiple simulations, you get a specification that behaves as expected. This set of requirements defines the expected behavior of the headlights of your car. What about its compliance to high-level properties such as safety requirements, or any other property important to you? This could be seen as a safety requirement. When in the automatic mode, when the ambient light is low and the headlights are already on, the system should maintain on. Let's see if our specification meets this safety property. This is a test environment for the specification. We drag and drop the specification in the blue box. The green boxes contain some constraints on the inputs so as to guide the simulation. For instance, this scenario will change the switch every 4 seconds. Let's create an observer and name it Functional Safety Observer. We drag and drop the safety requirement into the observer. You can now start the simulation. Let's do one execution of 500 steps. You can observe the inputs and outputs evolution and, here, the key information. The observer is red, therefore the system violates the safety requirement. Let's add the observer in the view. Here is the moment of the violation. If we double-click on the specification, we can see that all requirements are gray, meaning inactive, at the very moment we move to the auto mode.
We probably missed some initialization requirement here.
This is a second version with an additional requirement. Let's see if this correction works. I drag and drop the second version into the blue box and restart the simulation. Stimulus has generated exactly the same sequence of inputs, but this time the spec meets the safety. Let's do another execution with different inputs generated by stimulus. Again, the safety requirement is respected. We can also see that 100% of the requirements were covered in this execution. Let's now do 100 executions in one shot. The safety observer is still green. You can perform thousands of executions of your specification automatically using numerous combinations of inputs generated by stimulus. Very often, you will find safety violations that manual reviews would have not revealed. Stimulus allows you to achieve easily the very high level of confidence that you need for critical systems. You can test the code or FMUs generated from various implementation tools as easily. Load into Stimulus the log file of the tests you performed in your HIL environment, containing the inputs and outputs that occurred during the tests, and Stimulus, again, will assess if the safety was violated or not. Stimulus is your very effective companion to achieve your functional safety goals. Try stimulus.